One last topic we need to discuss is summarization. I'm going to explain summarization through an example, and we'll use a network we used in our previous lessons. All right, let's say that our router, the only one that we have in our network, instead of being connected to the internet, it's connected to another router, and then that router is connected to the internet. We're going to assume the IP addresses that we decided to give these networks in our previous lesson. So the network between the router and the switch on the left is 192.168.10/28. And then the three switches that have only two laptops connected to each one of them are /29 networks. And then we have another network between the two routers, between our old router and our new router. That's going to be 192.168.140. And notice that if we have a /29 here in this network, 192.168.132/29, that means that our last usable IP address in this subnet is going to be 39, and that's going to be the broadcast. So the next network ID or the next network IP address is going to be 192.168.140. And we're going to give it /30 because this is a point-to-point network. And a point-to-point network between two routers only needs two usable IP addresses, one for the interface on the first router and the other one on the interface on the second router. And then we need the network ID and the broadcast IP address. And with /30 network, that's what we get. We get exactly 4 IP addresses. The only network left to define is our public network, which is the network between our new router and the internet. So we're going to use 777.0/30. Now let's separate our private network from the public network. So this area right here is our private network. Now, if we were to look at this network from the internet, and just for the sake of this exercise, let's forget about these IP addresses actually not being routable on the internet. So if we had a router someplace on the internet, it would have to know about all of these subnets. So it would have to remember a route for 192.168.1.0/28, 192.168.1 16/29, 124/29, 140/30, etc., etc. In order to avoid that, we could just say to that imaginary router, all of the addresses or all of the networks that begin with 192.168.1 are here. So they are on this side of this public router, so to the left. So the only thing you need to do is just send a packet to this router, and then this router is going to know where all of the specific subnets are. The problem with that is if we had, for example, 192.168.1.128/30, for example, network somewhere else on the internet. So that would be an issue because we would have said to that imaginary router, okay, all of those networks are here. But then if one of those networks such as 128 or 192 or something like that appeared someplace else, then our routing would be incorrect. Because of that, we're going to scratch our /24 mask, and we're going to create a more specific mask to only cover those IP addresses that are in our private network connected to this router. What we're going to do is we're going to look at all of the networks that we have in this network, or all of the subnets that we have in this network. So it's 192.168. All of the subnets have their first octets like this, 192.168. And then they also have 1 in their third octet. But then the fourth octet is different in every subnet. We're just going to look at the network that has a highest value in its fourth octet, and that's this network, 192.168.140. So we need to think about what's the last usable IP address in this subnet, and that's 43. So 40 is the network ID, 41 and 42 are the two usable IP addresses, and then 43 is broadcast. Okay, so here we have all zeros, and this is our definite network portion if the mask is /24. But then this value is 43 in decimal format. And in order to create a summary subnet or a summary IP address, we need to look at all of the bits that are the same in all of our subnets. So it's definitely going to be 192.168.1. We can already see that without doing any math. But then the first two bits in our fourth octet are going to always be 0. That means that the number of bits that are always the same in all of our subnets is going to be 24. So this is 24 plus the 2 bits from the fourth octet. So that's 26. And that's going to be our new subnet mask. So 192.168.10/26 is our summary address for this entire network. Now we are safe in case a new network appears. For example, let's say that's network X and its subnet is 192.168.164/26. So now we're okay because all of our IP addresses in our existing network or our existing summarized network are going to range from 192.168.1.1 to 192.168.163, which is actually what you would get if you would try and make a broadcast IP address for this subnet. So if this were one simple subnet and you knew nothing about it, just looking at it from the outside, and you try to get its broadcast address, that's the last IP address in this subnet, it's going to be 163. So the very next IP address, which is 164, is a perfectly usable IP address that can be used in any other subnet. So the range for this new network X would actually be 192.168.165 to 127. So we're perfectly safe to use this summarized IP address. But don't worry, we're going to practice some more, and we're going to go through some more examples in our future lessons.